This is the instructional video for adding and subtracting polynomials. So in our notes today, the first thing that we talked about were algebra tiles. So just as a reminder, the large algebra tile that is x by x for its dimensions represents an x squared, because x times x is x squared. The rectangular shaped algebra tile that is 1 by x, it is represented by x. And then the small square that's 1 by 1, it represents 1. Okay? So if you look here at the polynomial that was given, it says 2x squared plus 3x plus 2 plus x squared minus 5x minus 5. And they ask you to use algebra tiles to model that. So the first thing I'm going to do is just kind of sketch my algebra tiles. So I know that I have, for this first polynomial, I have 2x squareds. Oh, that's a terrible drawing there. Let me try that again. I have 2x squareds, so that's 1, 2. I have 3 x's, so 1, 2, 3. And then I have 2 1's. So 2 small ones. So this represents my first polynomial. Then I am supposed to be adding an x squared. I have negative 5x, so I have 1, and this is negative, 2, 3, 4, 5 x's. And then a minus 5, so my little negative ones. Okay, so this would be the concrete model that represents this problem. Then if you notice here, the next thing it asks us to do is to combine like terms and write the resulting polynomial. So when you guys were in pre-algebra or 8th grade math, hopefully you guys saw how to kind of utilize these algebra tiles. So what you should know is that your x squareds, you can simply combine them because they're all positive. So I now have 3x squareds. I can count them. I have 1, 2, 3 x squareds. Now let's look at our x's. So notice they have different signs. So when you put a positive and a negative together, that makes what's called a zero pair. And a zero pair, what happens is it makes 0. So I know that this kind of cancels each other out. They make 0. So once I do that, I notice that I'm left with 2, and they're minus x, so negative 2x. Then I do the same thing with my 1's. So I notice I'm going to have those 0 pairs again. And then I count what's left. So I have a negative 1, negative 2, negative 3. So minus 3. So the resulting polynomial is 3x squared minus 2x minus 3. Now that was explained using a concrete model. So I actually was able to count and show you where those numbers came from. Now at this point in the year, hopefully you are comfortable enough that you could have just combined the algebraic model up here. So I see I have 2x squareds and a 1x squared. That makes 3x squareds. I have 3x's minus 5x's, which makes negative 2x's. And I have 2 minus 5, which is negative 3. Remember, when you're adding, all you're doing is combining like terms. So my x squareds go with my x squareds, my x's go with my x's, and my numbers go with my numbers. Remember, those are called constants. And don't forget, the sign in front of the term belongs to it. Okay? Let's try another one. So these problems are set up vertically, which is how you guys learned to add and subtract like multi-digit numbers. So it makes it just a little bit easier, I think, to organize your work. So it says to find each sum or difference. Notice here, this is an addition problem, so I simply add my like terms or combine my like terms. So a negative 3xy squared and a positive 3xy squared cancel. If I have 5 xy's and 8 xy's, that's going to make 13 xy's. If I have 4x squared y squareds and 6x squared y squareds, that's going to make 10 x squared y squares. So notice in order to add or find the sum, all I'm doing is I'm working with the coefficients of my numbers and I'm bringing my variables down. Okay? So that is addition. Now finding the difference or subtraction is a little bit different. When you subtract, you have to add the opposite. So that means that I need to distribute a negative to each of my terms. So in order to subtract, I need to make sure that the 5m squared turns negative, the 6m becomes positive, and the 17 becomes negative. When you distribute the negative, it changes the signs of all your numbers. And then you use the same thing we used for addition. So we have a negative 11 and a negative 17, which are going to combine to make negative 28. We have a positive 2m and a positive 6m, which are going to combine to make positive 8m. We have an 11m squared and a negative 5m squared. So when I do 11 minus 5, I wind up with 6m squared. And then that is my answer. Don't forget to distribute that negative when there is subtraction. That's one of the things that is most difficult for students. Let's look at another problem. So now we have an application problem here. They are telling us that they've given us the measures of two sides of a triangle. Notice I have a triangle here, and this side is labeled and this side is labeled. They're telling me that P, which they gave me P here, is my perimeter. They want us to find the measure of the third side. So when you first look at this problem, you might be overwhelmed by all the pieces, but you need to think about how would you solve this problem if there were just numbers. So if I was given the perimeter and I knew two of the sides and I wanted to find the third side, what I would need to do is I would need to combine the two sides that I know and then subtract that from the perimeter. And what's left over would give me my missing side. So that's what I'm going to do here. So the first thing I'm going to do is combine the like terms. So I have an x squared and a 2x squared. That makes 3x squared. I have a 3x and a 3x. That makes 6x. I have 6 minus 5, which makes positive 1. So what I just did is I added this side to this side. Now I know that if I take the perimeter and I subtract what I have, it will give me what I need to know. So what I'm going to do now is I'm going to move my perimeter equation down here, lining up my like terms. So I have 4x squared plus 5x plus 5. Now remember, on the last slide I told you that when you subtract, you have to distribute a negative. So the 3x squared becomes negative, the 6x becomes negative, and the 1 becomes negative. Now I can combine like terms. So I have 4x squareds minus 3x squareds, which makes 1x squared. I have 5x's minus 6x's, which makes a negative 1x. I have 5 minus 1, which makes positive 4. What this tells me is that the missing side right here is equal to x squared minus x plus 4. Okay? All right, let's look at another one. So this problem is similar to the last one. It tells us that they want us to find the area of the shaded region if the area of the total region is 5x squared minus 4xy plus 2. So they're telling me the entire rectangle's area is 5x squared minus 4xy plus 2. However, they want us to find just this shaded region. So notice these two little white pieces in the rectangle. In order to find the shaded region, I would need to subtract those from the total area, which is what I'm going to do. So I know that I want to subtract x squared, and I also want to subtract xy. Those are these little pieces inside my rectangle that I don't need. So notice there's no constant being subtracted from 2. So 2 and minus nothing, I just get to bring down that 2. So it's positive 2. Then I have a negative 4xy and a negative xy, which makes negative 5xy. Then I have a 5x squared minus x squared, which is 4x squared. Therefore, the area of just the shaded region would be equal to 4x squared minus 5xy plus 2. Okay, so the majority of today's lesson was somewhat review. It was just combining like terms. However, now that we're dealing with some exponents and multiple variables, you may need some extra support. If this video was not enough to make you feel comfortable, please make sure you're coming in for tutoring. And I will see you tomorrow. Have a great day.